Hello world, welcome to this part of the series. Today we are going to learn about creating tables. We've been working with tables like picking information, filtering, ordering, and every sort of operation we've been learning. But the tables we've been working with, they are not our own tables. In fact, there are sample tables that come with Oracle when you install it. In this session, we're going to learn how we can create our own table, and that will be the start of our journey on how we can insert, delete, update, and every other sort of data manipulation. To start with, when you're creating our own tables, we use the create table keyword. Create table keyword is one of the statements under the data definition language we looked at when we were looking at the introduction of SQL. If you didn't watch it, you can watch it from here. When you're creating tables, we must have a table name. And this table name should never have spaces. Just like we have a table name, we also have column names. Both the column name and the table name should never ever have spaces. If there is any situation where the table name or column name has more than 2 words, then we join the 2 words using the underscore, or we can just join them all at once. We must also have the data type. Data type means which kind of data will be stored by that specified column. For example, if I'm creating a table called movies, it may have a column called movie name. In the movie name, we have to define which kind of data will be stored in this column. Will it be numerical data? Will it be text? Maybe dates. So data type specify the kind of data a particular column will be keeping. Then we should have the number of characters. For instance, we can decide that a movie name should not exceed 100 characters. So any movie with more than 100 characters, it won't be allowed. So we have to reduce the number of characters to match the specified number of characters. Finally, we can have constraints. The business rule. For example, we can say that this column should never ever be left empty. When you are filling forms online, we always find something like this. Let's use this website called the Namgongo Hotel. I need to make a booking or to contact them. This is what happens in our everyday life. So when I click the contact, I come to this form called leave us a message. This is a form that is used by the users of this website to send a message to the owners of the website. We are seeing it as a form, but in actual sense, it is a table. It had the name column, the email, the subject, and the message. We can decide that the name field or email should never ever be left empty. When we submit, let us try to submit and we'll see. You can see that they're saying the field is required. The field is required. That means that we cannot submit this form unless we have the name and the email. Now when I try to punch in my name and my email, you can see that when I submit, I didn't put anything in the subject and the message, but they're saying the message has been sent. Why? These two can't be left empty. The name and the email can never be left empty, but we can leave the subject and the message. Now, back to when you are creating tables, we can decide to put a constraint. Constraint means the business rules. For example, we have seen that form. It doesn't accept submission unless we have a name and an email. When they are creating that table for the hotel reservation or the contact form, the column for name and the column for email, they had a constraint that doesn't allow any submission unless there is something filled. So that is what we call the constraint. Among the common data types we have the voucher or voucher 2. Then we have the number, date, timestamp. The voucher 2 or voucher, it is used for variable characters, most especially the text, letters, or alphanumeric characters. A to Z and 0 to 9. It is a mixture. For example, if we need the name column, any name should always be in letters A to Z. We don't expect any name to be in numbers. So if you are having a column that will be used to store names, the data type will be varchar or varchar2. For email, for example, email, an email is always a mixture of letters and numbers and special characters like the @ With the email, we can use the varchar or varchar2. We also have another data type called the number. The number is used to store numeric values. Then we have date and timestamp. These two are used for dates, but the date is used for only date, and then the timestamp, it is used to store date and the time. So those are some of the most common data types used whenever we are dealing with data, whenever you are dealing with data types in Oracle. We also have what we call the constraints, like we've mentioned, the business rules. We have the primary key. The primary key is a unique identifier of the record in a database. For instance, we can have a students table storing student records, but sometimes we may have students with the same name, exact name, and they're in the same class. How shall we distinguish these two? We can use something called the primary key, a unique identifier. We could give them IDs to distinguish one person from the other. That means the ID will be unique to every record in the database. So for that case, the IDs we give to the records, the ID becomes the primary key. Then we have the not null. Not null means something. It means you can't leave this field empty. So when you're back to our example of the contact form for the other Namgongo Hotel, the email and the name, we are given a constraint called the not null. We cannot leave it empty. So not null is used whenever we don't want a particular column to be left empty. Then we have the null. The null is the opposite of not null. So with the null, it could be left empty, just like we saw the message and the subject. When we submitted, they accepted even if there was nothing in them. Then we have the foreign key. A foreign key is used when we are bringing a relationship between two or more tables. We have this ERD or entity relationship diagram. We are going to use this diagram in a few minutes, but I want us to see something. We have these tables. This is a table, this is a table, and these are just columns for each table. We have this table called the faculty table. Now this faculty table has a primary key called the faculty code, meaning this column will never be left empty. Then we have the name. But the faculty table is directly communicating with the department table. And when you see this, it means that these two tables are related. Now, we have the faculty code here, and we also have the faculty code in the department table. This means that these two tables are related. Now, where it is coming from in the parent table, this is called the parent table. This is a primary key. And when this column is reflected in any other table, wherever it is reflected, it is a foreign key. For example, in the department table, the faculty code is a foreign key. Why a foreign key? It is a primary key from another table. So foreign keys are used to enforce relationship between tables. Now this means that in the department table, when I'm filling in maybe any department, I'll fill in the department name and the department code. Now when I'm giving a faculty, when I'm assigning a faculty to a department, the faculty record should be existing in this table, in the faculty table. Let me repeat that. Each department must have a faculty according to this, but we cannot assign a faculty to any department unless that faculty is there in the faculty table. For example, I have the faculty of computing here, only faculty of computing in this table. Now when I'm having a department called maybe Department of Marketing, and I'm assigning it a faculty called Faculty of Marketing, we shall get an error simply because we don't have Faculty of Marketing in the faculty table. We only have the Faculty of Computing. We don't have the Faculty of Marketing in this table. So the foreign key is a constraint we use when we are enforcing relationships between or among tables. Then finally we have another constraint called the unique. Unique means we need unique values. For example, we could say email. When we are creating email addresses, they always tell us the email was already taken and they give you suggestions. Why? In the database for Google, email addresses have a constraint called unique. They have to be unique for every user. So with the unique, it simply ensures that no record is repeated again. Every record must be repeated. And talking about unique, a subscription to this channel will be unique. So let's see this. So we are going to create a table. So we are going to create the faculty table first, then we shall go to the department, maybe all other tables. So let's begin with the faculty table. It has the faculty code and the data type is varchar and it is accepting 7 characters. We also have another column called the name and the data type is varchar and then it has 100 characters. That is the maximum number of characters that could be accepted for this column. So let's look at this command. We are beginning with the create table statement and we are bringing the table name, which is the faculty. Then we are opening brackets because we have multiple columns, but if a table has one column, the brackets are optional. But since we have multiple columns, we have to put them in brackets. So the first column is the faculty code. You can see that since the column has 2 words, we can't put a space. We have to join the 2 using an underscore, or we can just join it as one word. So this is the column name, faculty code, and then it is having a data type called varchar. Then we are specifying the number of characters to be 7. The number of characters has to be wrapped in a bracket. So we have 7, meaning this faculty code won't exceed 7 characters. Then the constraint, we are giving it the primary key. We are making this faculty code the primary key, meaning the faculty code will be unique for every faculty. And then we have the faculty name. After the first column, we put a comma. Then after the comma, we start another column. We have the faculty name, then varchar or varchar2. We can use either varchar2 or varchar. Both data types are right, but it's better to go with varchar2 since it is the latest, supported by Oracle. So varchar2 is the data type for this faculty name. Then we are specifying the number of characters to 100 and we are giving it a constraint code not null, meaning we can't leave this faculty name empty. There should be something in this faculty name. Then finally we lock the brackets. This opening bracket has to be closed at the end. So in run, we can see that the table has been successfully created. We can create another table. We can create the department table. We have the department code, the name, which doesn't exceed 255 characters, and then the faculty code for 7, won't exceed 7 characters. We are going to use foreign key to reference this code. So we have this create table. The table name is department, and we have the department code. It is a varchar and doesn't exceed 7 characters. It will be our primary key. Then we have the name, which is taking not more than 255 characters. We can decide to put it as not null because we can't have a department unless it has a name. Then we can have this faculty code, which is referencing the faculty table, and in the faculty table we are specifically looking for the faculty code. So what will happen is this faculty code, since we have already specified it here with all the data type and everything, we are just referencing it because it is a foreign key. So in the department table, we are putting the faculty code and we are referencing. Reference is the faculty table. You can see that we are referencing references, then the faculty table, and in the faculty table we are specifically looking for the faculty code column. And when you run this, you can see that the table has been successfully created. So there is no need for us to redefine this faculty code with the virtual 7 because we are already we are just referencing it. We are just referencing it from another table called the faculty. So when we say references, we mean the foreign key. We are just referencing this column in another table. We can create the last table. We can use the course table, and it had the course code, the title, the credit unit. Here the data type is shown as int, but we are not going to use int because int is not available in other database platforms, but not in Oracle. In Oracle we shall use the number rather than the int. So we shall substitute this to number. Then we also have the program code, which is referencing in the program table. However, we cannot create this table unless we have already created the program table, simply because the program code in the course table is referencing the program code in the program table. So there is no way we can reference something that hasn't yet existed. So to create the course table, we have to create the program first, simply because of this program code column that is being referenced from the program table. So we have to create the program table first, and then we create the course table. You may say, let me first try it. Let's try it together and we see. So in trying to create this or proving our mission, we are trying to create the course table with the course code with this virtual and primary key. This is having a title, and we are giving it the credit unit. However, we are changing it to number because number is a substitute for int in Oracle, and this time we are giving it null, meaning that this credit unit could be left empty. Then we are having the program code, which is referencing the program table and specifically the program code. But we are sure we shall run into an error simply because this program table is not yet created. Let's try to see. So you can see that we get an error 00942 error because the table of view we are trying to reference doesn't exist. So we need to first create the program table and then we create the course table. Let's create the program table. So we are going to first create the program table, and then we have the program code, the virtual. It is having a title and then the department code that is referencing the department table. When we run this, the table has been created. Now we can rerun our previous statement for the course and it will be created. So when you run this, you can see that the table is now created after getting the program table that it is using to reference the program code. Final about tables, we can create a table from an existing table. We can use the existing table to create new tables. To do that, we are going to just create the student table. However, we are not going to create all the columns. Let us create a student table using the employees table we already have. In the employees table, we're going to just pick the first name, last name, and email. These will be the only things we're going to pick from the employees table to create this table. The rest we shall create them in other episodes. When you're creating a table from an existing table, we use the select statement. We say create table and then we give it the table name. Now we say the as, we use the as keyword, and then we run the select statement. And it normally comes with all the information. When we are creating a table from an existing table, it comes with all the information in the existing table in this new table. Let us see this in action by trying to create the student table with only 3 columns, the first name, last name, and email, using the existing employees table. So let us try this, and we say create table students as let's picking the first name, then the last name, and then the email. There is no need to define which columns we are interested, because the columns are going to come with the already existing table. So the first name column will be part of the student table, the last name, and email. We can do all sort of filtering. We can say that we only need people who are from, whose name is maybe a B, or they were hired between these, or whose salary. We can do all other filtering. For example, we can say where the first name, like only those starting with a B, since I'm Bashir. And then we can also modify this email. We saw that the email in the employees table, they are not so good. They're in uppercase and they don't have an extension. So we can decide to change this here by using the lower. You remember this? So we can improve on the email by concocting this, the current email with the @gmail.com, and they will be returned in uppercase, in lowercase. If you don't know how we do this, you can watch the character functions using this link up. So we are changing this with the concact, then we are concocting the email with @gmail.com, then as email, which will be our column name. So when you run this, we are running into errors, probably because we didn't close one of the brackets here. We left one bracket open, which is the one here. So we can go back and we fix this, and when you run, you can see that the table is now created. We can try to select any information. We can try to say select star from this new table called students to see if the records are really there. So when you run this, we can see that the names have really come, and it is only Bruce and Brittany, those names whose first names are starting with a letter B, with their emails. So that is how we create tables. We create tables using the create table keyword, and we always use this syntax: the create table, then the table name, then the column name. The table name and the column name should never have a space between them. Then the data type we specify using any of these data types we have mentioned. Then we specify the number of characters, and lastly the constraint. We can add the constraint or we may leave it. It's not compulsory that we should have the constraint. Then we can also create tables from existing tables with the help of the select statements. So that's it for this session. We shall meet in the next episode with modifying created tables.